For programming a MillTurn in SurfCam, the best way we have found is that the coordinate system going to the post is in machine space. In other words, here's SurfCam X, SurfCam Y, SurfCam Z, and this is machine's coordinates basically. Now, to achieve this, we always set a machine datum as something that is either the right end or parallel to right side view. This allows programming for lathe work in CView 1 in traditional SurfCam fashion. The other thing we need to know is if there is a sub-spindle, we need to know the precise distance between where 0 will be on the main spindle and where 0 will be on the sub-spindle. In this case, 3.35 inches. And what we do for this, if we're doing main and sub work, we can put in an inline command that has the overall length that sets that. So what happens when we're programming in the sub-spindle, the system adds 3.35 inches to the 0, which is still here coming from SurfCam, so that this becomes the 0 point, coincident or congruent with the work offset, typically G55 on the sub-spindle. So to continue, if we use this technique, then we can use normal SurfCam coordinates for the turning work in CView 1, and we can use literally any other standard process. We can program in different views, and so on. So now when we do transfer, we use a special inline command to tell the post to transfer, and from that point on, the post considers that the part is in the sub-spindle and it applies the shift. So if we post this job, in this case on a Doosan, the main and sub-spindle, and we look at the NC file, we'll notice that all the paths have an SP1 for when the part is in the main spindle, and then SP2 when we're in the sub-spindle. And this logic, which is here, is the transfer logic that was set up in the setup.dat file that causes the machine to do the physical part transfer. And again, on this particular machine, we had 3 different styles of part transfer. And that was a simple transfer, a pull and cutoff and transfer, and a third custom transfer. So anyway, using this technique, this allows us the freedom to use and place a C view anywhere on the part that's near a particular feature in order to do some programming there and have the feature relative to it. Again, everything gets converted into a global coordinate system when the file is presented to the post processor. So it really doesn't matter where the origin of our C view lives. And in this case, I've got it on the corner of this flat face here at 45 degrees. To illustrate the coordinate system shift, we'll look closely here at a threading toolpath, and the thread start point is at an X of 3 in SurfCam and a Y of 3.5, which is 0.3 in Z on the machine and 7 inches in X. And if we look at the file coming to the post processor, we will see that the thread is, well, there's 3.5 here in X, 0, Y, and Z of 3. And this has been converted because of the machine datum. And so that's the data going to the post. And it is set up to output this value here as in the Z position. And of course, it's putting out X of 7 for the Y position, or for the diameter. Now for threading, we're doing multi-start threading here. The number of starts is 2. There's 2 starts on this particular thread. And since SurfCam has positioned us to a Z of 0.3 to start the thread, what the post is doing, it takes the lead value and it takes and adds that in Z to start the thread a little bit further out, ending the thread at the appropriate point that's called out for in the program. So this chases the first thread, and then this one chases the second thread. And then this is our pull-out move to get back out, and so forth and so on. So to recap, again, we use a machine datum, and that's critical. This allows you to program lathe type of tool paths in standard SurfCam mode. So we program for the front of the part here. We'd program over on the plus Y side over here for doing an ID bore if we were doing any turning on the sub-spindle and so forth. And then in the grand scheme of things, we set the overall length with an inline command up here, and then we tell the post to transfer, and the tool paths are then used for programming from with the part in the sub-spindle, and it calls the sub-spindle logic at that point.